Okay, well, it's a great pleasure to welcome back Manjir, because Manjir spoke for us a few years back and a real tour de force performance. And for those of you that haven't yet met Manjir, well, she is a lady who is doing fantastic work in trying to blend consciousness research with science, with physics, and joining the dots that, shall we say, some people in the usual academic elites refuse to join. And yet, I think it's only through making these connections with other areas that is ever going to make any real sense of what's going on. And some of you will know the book Punk Science. You know, that's been a fantastic book because it's reached out beyond the choir and helped bring physics to a new audience and opening it out to other subjects. And tonight it's going to be opened out even further, because we're going to hear a lot of connections being made, from everything to do with black holes to the Shroud of Turin, which some of us heard about a little bit yesterday, and also the biblical flood. So all of these things somehow connect up, and I'm really looking forward to finding out how. So a big warm welcome for Dr. Manjir Samanta-Laughton.
Thank you so much for welcoming me back, and it's astonishing to see so many of you here on a warm, sticky summer evening. This is a really important day for me as well, because although some of you may be familiar with my work, Punk Science and the Black Hole Principle, today I'm going to be presenting new information on that theory for the first time. New evidence for the first time in the UK, and I'm also going to be connecting the dots with things like the Shroud of Turin and the biblical flood. So there's some really, really new information. I just got back from the US, where I was just been speaking at the Institute of the Noetic Sciences, if anybody has heard of that. And so that's the first time I was presenting this new evidence, and it went down an absolute storm. So this is the first time I'm presenting this in my homeland, and the first time I'm bringing it together with these, seen as more sort of religious or esoteric subjects. So it's a very significant day for me, and I'm so glad that I can be presenting it here in Glastonbury. Sorry, I just knocked my mic. Am I okay? Okay, brilliant. Okay. So what I'm going to do today is just recap a little bit about, first of all, what is this science and consciousness stuff anyway? Then look at the black hole principle. Some of you will be familiar with it, so we'll just do a recap of that. And then we're going to go into the new evidence. And literally, this has just come to fruition in the last 6 months or so for me. So we'll go into the new evidence, and then what that evidence means for things like the biblical flood and also the Shroud of Turin. Does that sound okay? Yeah? Okay. So just to do a recap, I know that you all know parts of this. So as a lot of you here know, we've been living with this concept of the clockwork universe, this sort of reductionist Newtonian paradigm where everything is solid and everything works like clockwork, and the atom is the deepest thing that we can look at. When we started to look into the atom, we actually found that it worked very differently to how we thought. And actually there was lots of empty space that we found, this cloud of electrons around the nucleus. So stuff that we thought was so solid we ended up realising that it was not so solid after all. And then it came along quantum physics and this concept of wave-particle duality, where depending on how you looked at something actually determined its behaviour. So this brought in a whole new concept of the fact that our perceptions, the way that we observe and the way that we measure, actually changes and interacts with reality. So you have this concept called wave-particle duality, and that is until you actually measure something, it exists as a sort of wave of probability. It is actually a sort of function. So this isn't a wave as in, this is like something physical, like a wave in the sea. This is like a wave of possibility, where something might be. And it's only when we measure it does it collapse into a particle. So does that sound familiar to people here? Yeah, okay. So, good. So, what's the consequence of this? Well, it does mean, as I said earlier, it could mean that consciousness interacts with our reality. But the reductionist paradigm tells us that consciousness is like a side effect of the brain. It's like an epiphenomena of the brain. And so the brain is like a piece of meat, and it just has lots of firings going on. And those firings, although we don't understand them, science at the moment is assigning everything, all of our inner experiences, to this lump of meat in our heads. And so very sophisticated, but it still is a physical thing. So our inner experiences, this is sometimes known as the hard problem of consciousness. How is it that these firings lead to our inner experiences and our memories? That's a big puzzle in neuroscience at the moment. And some physicists have gone even further. Once they realised that quantum physics was saying that our interaction with reality actually causes this wave of possibilities to actually collapse into actuality. So before you look at it, you know, there's nothing there. You know, there's just a possibility, there's information. But when you look at it, when you measure, it collapses into actuality. So some physicists have gone, well, what does that mean? Because the brain itself is actually made up of atoms. So if the brain is producing consciousness, but consciousness itself is responsible for bringing atoms into being, then what came first, the brain or consciousness? And that's what Amit Goswami calls the brain consciousness paradox. And the way that he solves it, and the way that some physicists have been solving it, not all, this is by far the minority of physicists have been solving it this way. Most of them just have a saying, shut up and calculate, which actually means don't think about the consequences, just, you know, do your work. And a lot of physicists don't really take on board the magnitude of the consequences of quantum theory. They call it weird, and they call it the measurement problem, because they actually want to get rid of it. It's a problem. But we've not been able to get rid of it in almost 100 years. So some physicists say now that the only way to resolve the brain consciousness paradox is by saying that consciousness is fundamental. So consciousness, and that's what's going to form the basis of what we're going to be talking about today. If you understand that from logic, from quantum theory, some physicists, not all, if you go to your nearest quantum physicist and say, you know, consciousness is fundamental, they go, what are you talking about? You know, they'll say, well, quantum physics is weird, but it's not that weird. You know, that's their stand. So this is a minority of physicists, but it's out there in the scientific realm that actually consciousness is the ground of being and everything else arises from it. Okay, so far so good? Okay, brilliant. So what I'm going to go on to today is talk about something that could be seen as a unity theory. I actually believe that we're never going to get a unity theory, because the insight that I got when I got the black hole principle through also told me just how vast and infinite the universe is, that a human mind actually could never comprehend the vastness of the universe. It's just impossible. And what I'm going to present today, although it could be seen as another leap in science, it actually is just the next step. You know, and that kind of keeps it humble and keeps it, you know, within. But in physics itself, they are always looking for a unity theory. And within places like the Institute of Noetic Sciences, they are not only looking for a unity theory, they're looking for something that's going to unite everything, all the forces of physics, with consciousness as well. You know, so today, that's what we're going to be talking about first, and then going on to this new evidence. So a lot of people have been looking for a unity theory. We've had, you know, people like Emily de Châtelet. Anybody heard of her? Yeah. Okay. So she was one of the a big physicist in in Newton's day, and she actually translated some of Newton's work into French, which is still the main textbook in France. And so also things like Faraday brought together electricity and magnetism, so we now call it electromagnetism. He first started to realise that, and Maxwell's equations brought that together even further. Of course, people recognise this famous equation, equals mc squared, so space and time coming together. And in recent years, we've had a really good attempt at unity theory and string theory, where mainstream physicists are actually saying that the universe, everything in the universe, all the forces, all the particles, are actually made up of vibrations. Which, this is mainstream jobbing physicists, and they are actually, these vibrations are actually vibrating in many different dimensions. So, even string theory, so even mainstream physicists are saying things which sound extraordinary, like the ancient ideas of Vedic literature and so on and so forth. So we seem to be coming all the way around, but the main point of all this is that they're trying to unite the forces of the weak and strong nuclear forces, the forces of electromagnetism, and also the force of gravity, things that are ruling the sort of big objects that we see in the cosmos, and trying to bring it all together with all of these particles that we see in our particle accelerators. There's a big push in physics to do this. So what I'm going to present is why I think the black hole principle is the next step to this. This is something that I haven't sort of just thought up. I actually was given it in a vision, a very, very powerful, not just a vision, I wasn't seeing it in front of me. There was a moment back in 2003 when the universe actually opened up, and my mind, my consciousness became one with an aspect of the universal consciousness. And that's why I can act with such conviction with this, because it's not from me, it's not from my intellect. It happened in a revelation. And I'm a medical doctor by training, and I have the scientific sort of background, some scientific background, to actually piece all the research together to make this a theory that's suitable for the 21st century and for the modern telescopes and modern astrophysics we have today. Because that's important for our time. We need to have the proof. So we're going all the way round from the mysticism back to the same principles, but we've got the proof this time. So I believe that something very, very great sort of happened to me 10 years ago. And I spent 10 years looking at the evidence and making predictions that have actually come true. So I'm going to actually talk about that today. So we're going to talk about, the way that it unifies it with consciousness, going beyond the speed of light, all of the evidence and predictions that I've been talking about, the link with water and the new meaning, and why it could be an explanation for the Great Flood, and why it could be significant for the Shroud of Turin. So that's what we're going to be covering today. Sound good? Yeah? Okay. Okay, just in case you're just walking out the door. Okay. So this is a story that we have been told. This is a story that scientists tell us, that the universe started with a big bang. Yeah, everybody heard this one? So, they don't tell us what banged, or why it banged, or what was actually there before. And I don't know if you've heard of Neil Turok of Cambridge University, but I was actually at one of his presentations at the Institute of Physics, and he actually had a slide of the early universe where he actually had a gigantic hand that was actually getting everything going. And, that's the best that they can do to explain why, the Big Bang really defies all of their laws of physics. But 15 billion years later, this is the situation that we're in now. So we have something that they call the standard model of cosmology. We have the standard model of particle physics, and this is what they call the standard model of cosmology. And when they started to piece this together from their kind of, it's called the microwave background, when they started to piece this together, there were celebrations because finally cosmologists could call themselves proper scientists. because they actually had data. Because normally when it comes to the whole universe, well, science works on repeated experiments. And so that's what cosmologists do. They look at the whole universe. Well, you can't have a repeated experiment with the whole universe. So they didn't really feel like they were true scientists until this moment. And they announced with a great flourish and celebration that they knew what the universe was all about. And so this is what they came up with. That it was 73% dark energy, which they have no idea what it's made of. That it's another 23% dark matter. Again, they have no idea what that is. And then you've got this sort of intergalactic gas, and everything else, which is like the physical stuff that we see in the universe, from stars to galaxies, the stuff that we can actually visibly see, and including us, including everything that we're actually visibly seeing, is this 0.4% stars, etc. So we fit into the etc. So even though there were celebrations at the time, it's safe to say that it's not really a big picture, not really a full picture. And so this has actually led to some people asking some questions. And there was actually a BBC documentary, Horizon, a couple of years ago now, called What If Everything, it was something like What If Everything We Knew About the Universe Is Wrong. Did anyone see that? Yeah, I got lots of phone calls and emails that night going, oh, what you're saying is right. And it's like, hang on a minute, why was when I was saying it? It was, so a lot of people don't know that there are problems in cosmology because they get a lot of their information from TV programs that are making out that everything is sorted. Scientists like to tell the public, don't worry, we know what's going on, we have all the answers. It ain't the case. And this is one of those rare programs that actually said, you know what, we might have got it all wrong. So this is a guy called Pedro Ferreira, who's, I don't know.
An interesting time where we're up against how perfect a model it might be. Maybe the standard model is wrong and you have to come up with a better model. Okay,
so you're hearing it from the academics themselves. They're wondering, have we got everything wrong? So this isn't just people from the fringe, or, this is the mainstream. He's at Oxford, an Oxford physicist, who's actually saying, maybe we've got it wrong. Okay, and some of these problems, is everyone following so far? Yeah, I know it's a lot of science, but okay. So some of these problems come up with the Big Bang and with the sort of inflation theory. Have you heard of inflation theory? Yeah, okay, well, things very, very rapidly expanded in the early universe. So somebody's won a Nobel Prize for that. But these are some of the problems that we have with Big Bang Theory. You might not hear about this a lot. I mean, you might not hear scientists actually say, you know what, we don't really know what's going on, because, as I said, they like to put about this very, placid front to the public, like, we know what's going on. This is known as the flatness problem. And it's just a bit of a complicated diagram, but it's not as bad as you think. What it means is that as things expanded, as the universe expanded out, you have all of the gravitational pull, pulling, all the stuff in the universe, pulling on each other, yeah? With the gravitational pull. And you also have all of the expansion force actually pulling out. Now, the density, the actual critical density, is a very fine line between collapsing in on itself and blowing apart, yeah? And for some reason, our universe got it right. And so our universe, effectively, is flat. Instead of sort of curving or, blowing apart, you can see this is an open universe, that's a closed universe where everything's closing in. And we don't know why our universe got it right. And even though it doesn't sound like a problem, it is a problem, because scientists don't like it when everything is just so perfect. So that's one of the problems with the Big Bang Theory. It's called the flatness problem. And here's another one. It's called the horizon problem. Anybody heard of this one? No, because they don't tell you. They don't tell you they've got lots of problems. So the horizon problem is another issue, because wherever we look in the universe, no matter how far, everything looks the same. Now think about it, if you're going further into space, you should start, because light takes a certain time to reach us, you should be looking further in time, yeah? So as you look further into space, you should actually be seeing younger and younger galaxies, younger and younger stars, and we don't. Okay, and we should actually see sort of small fluctuations. Because if you think about the way the universe expanded, say it started there and it spreads out, yeah? After the universe expanded in a Big Bang, if the Big Bang is correct, light would have been created momentarily after the universe started expanding, yeah? So you then have light expanding out in a horizon, yeah? Okay, so the universe has got, say, to there a few seconds after the Big Bang, and light has got to there in a horizon, yeah? It's spreading out. Now, the areas that are not reached by the light, okay, should be different from the areas that were reached by the light. We should be able to see differences 15 billion years ago, and we don't. You know, and this is a big problem, and they call it the horizon problem. Okay, because as we know, light goes at a finite speed apparently. So, you know, if it's travelling at the speed of light, it just can't reach those areas. And those differences should be visible to us now. And it's kind of like if you take two boys that grew up on the same street and they go to different universities around the world and they meet back at, like, you know, the age of 40, they look identical. You know, that's kind of an analogy to what we see in the universe. So a team of physicists, these are mainstream physicists again, and this is a guy called João Gageiro, actually started to look at this and thought, we know how to solve this problem. So I'll let him tell you himself. We've got some subtitles just there.
When the morning, like this one, walking on these fields, I just realized that if you were to break one single sacred rule of the game, the constancy of the speed of light, you could actually solve your horizon problem.
Okay, so I think he was, where was it, Cambridge, I think, at the time. So he suddenly got this idea, like a bolt out of the blue. What if the speed of light was not constant? And everybody knows in physics that nothing can go faster than the speed of light. But he thought, what if in the early universe light went faster? Then there would be no problem. It would have reached all areas, and 15 billion years later, everything would look the same. Yeah? So that's the sort of idea that he had. But actually, in his mathematics, he went even further. And he was working with a group of people. If you do come across this book, Faster Than the Speed of Light, do read it, because not only does he talk about this theory, VSL it's called, varying speed of light, it also talks about the scientific process, how you only get peer review if you're in with the right people, and etc. It's such a very, very interesting book. He calls himself the punk physicist, which no coincidence. And he's based in a London university. He's a mainstream physicist. He's actually a professor. So what he actually said, going in even further, is that actually light is infinite. That it makes more sense if it's infinite. And what happens is light actually gets light actually gets curled up in these higher dimensions. Remember we talked about the higher dimensions, yeah? So we think that light is going at a certain speed, when actually, you can see those bottom arrows, it's going faster. It's just we don't see it because it's in higher dimensions. Does that make sense to people? So this is a mainstream scientist who has done the calculations and said, you know what, it makes sense that light is infinite, not that it's got a definite speed. So I started to think about this, and I thought, hang on a minute, what is the speed of light anyway? And even Einstein started to question. He actually came up with a rule, excuse me, he actually came up with a rule, and he actually started to question it in his lifetime. So just give you. So I actually started to think, well, what happens when you try to actually catch up? Sorry. What actually happens when you try and catch up the frog in my throat now? Oh dear, excuse me. Okay, what actually happens if you try and catch up with a photon? Because you're supposed to never be able to catch up with a photon, no matter how fast you go. So if a photon is going at 300,000 kilometers per second, if you go at 29999 kilometers per second after it, you will not catch up with the photon. You will, first of all, you become into infinite density because you have mass. So you will never, ever, ever get past that. But also, unlike if something in our world, so say I take Vicky, for example, and I see Vicky walking down the street, and I try and catch up with Vicky, so she's walking at a certain speed, and I try and catch up with her. I walk a bit faster to try and catch up with her. And so I'm then parallel with Vicky, yeah? And then I start to walk alongside Vicky. Now, relative to Vicky, I'm going at 0 speed, do you understand? Yeah, because we're both now going at the same speed. That doesn't happen with a photon. No matter how fast you're going, the photon is still going at 300,000 kilometers per second, even if you're going at very almost the speed of light. And I realised that a photon isn't a thing at all. And put that together with what we've talked about today, that consciousness is fundamental, that there's mainstream physicists, not all of them, I mean that guy Joao was seen as a heretic. You know, they actually called him a heretic, which is quite interesting. Obviously it's a religious term. And so put that all together, and I realised that you have something, a very different definition of the speed of light. I realised that you've got to redefine what we now call as the speed of light as something called the perception horizon. Okay, so I realised that the speed of light is not the limitation of the universe at all. It's actually just a limitation of the dimensions, of the perception, of this dimension. What we call 3D reality. Yeah? Okay, is everybody following that? Yeah? Okay. So I renamed that the perception horizon. It's not the limitation at all. There's some physicists, even Einstein was looking at a VSL theory. You know, because what Einstein said was nothing with mass can go faster than the speed of light. And people forget that part. And it's true that if you were to try and accelerate beyond the speed of light in your physical body, you wouldn't make it. But the reason is because everything with mass is in reference to this speed of light. That's why. It's a limitation of our physical world. So, but it's an underlying vibration of consciousness that everything is referring to in our physical world. So, but it's not the limitation of the universe itself. And that's where we make the mistake. So what is beyond the perception horizon? Well, do you remember all the dark matter and dark energy we were talking about earlier? Most of the universe is missing. Could that possibly be where that all is? It's just that scientists and the current paradigm are focusing on everything below the speed of light. Because that's all that they can conceive of. That's all that they understand to measure. You know, so when you understand that actually most of the universe is going beyond, and this dark matter and dark energy stuff, it's not dark at all. It's actually the super light, the super bright stuff. And what can actually go beyond this perception horizon? Mystics. Mystics have been moving their consciousness beyond these ordinary realms for, you know, as long as humans have been around. as long as cats and dogs are being, you know. I mean, who do we know who was actually more mystical than us? Well, it's the animals that surround us constantly use these dimensions. Okay, so, and we don't realise what they're doing. Anybody here would call themselves a mystic? Have you had some sort of otherworldly experience? Yeah? Okay, don't be shy, you're okay here. Okay, call the ambulance now. I had a Kundalini awakening when I was in medical school, when I was just 18, 19 years old in the first 3 weeks. And ever since then, I've been living a multi-dimensional reality. Qualified as a doctor, qualified as a GP, but I've been living a multi-dimensional reality. I've been able to feel energy from my hands. I've been seeing people who have passed on. You know, they come. I don't look for them; they just come into my life. You know, and my first experience of an angel was at 19 years old, and I've had many experiences of angels since. I have seen beings from that we would call alien beings. I've had encounters with them. I've actually gone into their ships and had a look, and you know, all that sort of stuff. So I live my life like this. And you know, I don't know who was here for Andrew Collins. Yeah. Okay. This is where it all is, beyond the perception horizon. And there are myriads of beings there, because beyond our usual consciousness, beyond that speed of light, beyond the perception horizon, there are many, many different levels. Okay, so we're piecing together the quantum physics, we said at the beginning, consciousness is fundamental, the string theory, with the dimensions of consciousness, and the perception horizon. Yeah? So we've pieced together bits of physics that are coming from the mainstream, that have experimental backing. And so it is here that the mystical experience really, really happens. Okay, so, and I'll go into some more of that later, but there are many different beings. Yes, they channel through people differently. So somebody might see Archangel Michael appearing. Some people might see Vishnu appearing, depending on your cultural background. But the actual frequency of consciousness, they really do exist. Okay, it's our interpretation. You know, so, but, you know, if you do know, I've had psychic experiences where, I mean, for example, I actually do see people who pass on people's relatives quite a lot. And, you know, I sort of say, I had a woman, a friend of mine, who was actually just at my kitchen table. And she appears to me as very young, you know, when my friend, you know, appears very sort of youthful. But actually she's more than like in her 50s. And her father, who had died when she was very young, sort of about 3 years old, came into the kitchen. And I was sort of a bit puzzled, because I was saying, okay, he kind of looks like James Dean. You know, he's got the T-shirt and he's got this... And I was going, but that doesn't fit, because you're younger than that. Why does he look like a sort of rocker? And she goes, you're forgetting how, you know, that my true age, what my true age is. And she showed me pictures, and I'd seen him quite accurately. So even though we are interpreting these things, there are these dimensions of consciousness that really are there. And I don't know, has anybody had a UFO encounter? Or have you seen that the orange glow that often is associated? Because there's an awful lot of orange, this peachy orange colour, that occurs with certain dimensional experiences. I've seen them personally around UFOs, other people have described this as well. And also the burning bush. You know, a lot of the biblical texts describe orange fire coming out of various objects. I think that this is a dimensional process, that when something is trying to manifest in the physical, from another dimension, this orange glow is a side effect. That's just a sort of hypothesis of mine. Okay, but does that make sense to people? Okay, so this is quite common, this sort of orange glow. Okay, so I just wanted to refer a bit to some of what we were talking about yesterday with the sort of mystical experiences and the different dimensions. But going back to the theory, we now have an explanation, perhaps, if I'm right, as to what all this dark matter and dark energy is all about. And where is the darkest place that we know? It's supposedly in a black hole. Okay. Now, everybody heard of black holes, yeah? Okay. And the story, again, we're given loads and loads of stories by scientists. When you look at the evidence, the stories don't really add up. So we're going to be discussing a bit of that as well. So the story that we're given about black holes, and I don't want to blame any of these scientists because they were working step by step with ideas that came progressively one after another. And it started off with Einstein's theories of relativity, where space and time could curve so much that you could get a place of infinite density and infinite gravity. And that meant you had this infinite gravity in the centre, a singularity, where everything got sucked in. And people came along and said, well, this is what could happen, a guy called Chandrasekhar, when a star of a certain mass collapses in on itself. At the end of its life, when it's burnt up all its fuel, it collapses in on itself and it creates a singularity. And those are the big monstrous black holes that we're told about. Yes, everybody know about that? And if something gets too close to its event horizon, for example, the crew of the Starship Enterprise, then you actually go through and you get sucked into the black hole. And when it comes to Star Trek, they always seem to miraculously last minute get out again. But supposedly when you approach the event horizon, strange things go on in space and time, and then you get sucked in. So that's the story that we've actually been told. Now, we didn't know if black holes existed or not for quite a long time. We're going back to Einstein's day when people started to think about it. Chandrasekhar was like the 1930s. He was an Indian physicist who came over, had terrible humiliation at the hands of Arthur Eddington, unfortunately, and ended his life being quite disillusioned with the whole scientific process. But Chandrasekhar, we take his name as one of the telescopes that we use now. It's a Chandra telescope. So there were people, John Wheeler in the 1960s actually coined the term black holes. Well, we think he did. He seems to have taken the credit for it. And he was actually taking the mickey of it, when he said this term black holes. So you have this concept of building and building. But until recently, we actually didn't know if black holes actually existed. There was actually no real evidence for it at all. And it's only since we've had the latest telescope evidence that people have been able to see black holes. And when we actually saw them, we were in for a bit of a surprise. And this is another case where the evidence doesn't fit the theory. So we'll just have a look at that. So I'm just going to need the sound again on this, so I'll just play this. So this is actually the physicists who were looking at black holes, and so they actually, to their surprise, found them absolutely everywhere. So I hope this is going to play on okay.
By one, we were seeing this picture sort of emerge out of the fog that every galaxy, almost every galaxy, had a supermassive black hole in it. It was really quite astonishing.
Far from being rare freaks of nature, the nucleus began to suspect that all galaxies could have giant black holes at their hearts. If this was true, it would revolutionize ideas of what a galaxy actually is.
Okay, so you're getting the idea from that clip that this was a big shock. They were actually looking at the neighbouring galaxy, Andromeda, just to do a sort of test run. And they found the signs of a supermassive black hole in the centre. And they started to look at the next galaxy and the next galaxy, and to their big surprise, they found supermassive black holes at the centre of each of them. And how do they identify them, you might be asking, because aren't they black? They suck everything in. Well, one of the ways they identified them was because the stars around the centre of the galaxies were spinning so fast. So they thought, well, only something of that sort of level of gravity would be doing that, according to their theories. And they also noticed that there was a direct relationship between the size of the supermassive black hole at the centre and the size of the galaxy. Now, at this point, most people would be thinking, do you think the supermassive black hole has got something to do with creating the galaxy? You know, because of this one-to-one relationship? But they still were holding on, and still are, holding on to their old ideas in the face of the evidence. You know, it's so difficult to break through once you're attached to an idea. So, they started finding black holes everywhere. They were even in our own galaxy. They were a bit nervous to look at the Milky Way to see, because they still think black holes suck everything around them. But they looked at our own Milky Way galaxy and they found that there was a supermassive black hole at the centre as well. Big surprise. This has been a big shock to people. And not only are they finding them at the centre of the galaxies, they're finding them all over the galaxies, and in sort of different sort of sizes. And not only that, they've also found some really, really strange things about black holes, because we're all told the story, are we not, that black holes suck in everything around them. Well, it's not really what they found. They actually found black holes give off quite a lot of radiation. In fact, you can actually identify black holes by how bright they are. Ironically, by how bright they are. So when you ask them, they go, oh, well, you know, that's because all the stuff going down the plug hole ends up getting speeded up, and then it gives off a few sort of, you know, radiation from that you know. But you hang on, you said black holes suck everything around them. Okay, right. So that's the story that they'll give you if you ask a physicist. That's what they'll say. But actually, what we've got is coming out of a black hole, time and time again, are electrons, which is particles of matter, which are nearly at light speed. Positrons, which are the sort of mirror image of electrons. They're sort of similar particles, but they're sort of, you know, the other charge or the other spin. So these are antimatter particles, and sometimes you get gamma rays coming out of black holes. So you have this sort of strange situation when, far from being black holes are actually really, really bright, and they're giving out all of these sets of radiation at all times. Now, I was actually wondering about this, and if you read my second book, The Genius Group, I go into why exactly I had the time to start pondering cosmology instead of seeing to patients, etc. So I was actually pondering this. A huge amount in my life happened, and I was out in the woods thinking on why all of this, how it all fits together, because it doesn't fit the normal theory and the normal view of black holes. And that's when I realised that I had that massive vision, that massive experience, and I realised we have it all wrong. So this is what was shown to me. It actually kind of wasn't a realisation. What I saw was that you still have this infinity at the centre of black holes, but this infinite light. Remember, Ramagedra said that light is infinite, and it expresses itself curled up in the dimensions. Remember I said that? Mainstream physicists. So it actually comes out of the black hole, this infinite light, and it gets to the edge of our perception. Do you remember the perception horizon? Yeah? And that's when the particle of light, the photon, splits into two. And you end up with a particle, an electron, which is the matter, and the antimatter. So those particles of matter and antimatter are mirror images of each other, and together they cancel out and they make light. So what you get coming out of the black hole is the light coming to the edge, and it splits into two, into its component halves. And I suddenly saw that is actually what's happening at black holes. They're not destructive, they are creative. And you have this spiral. I could go on all day about just spirals, but we won't go into that. So just to reiterate, so you've got the light from the centre of the black hole. It spirals around the dimensions, and it gets to the edge of our reality, the edge of our perception. And that's when it splits, And it becomes, so this is actually the perception horizon, which we call currently the speed of light. And that's when the photon splits into two, the matter and the antimatter. And what we see in our telescopes are electrons at just below the speed of light coming out of black holes because they've only just slowed down to our perception. Does that make sense? Okay, and some of you might have heard of the electric universe theory. Okay, and Andrew Collins did talk about the plasma a bit yesterday. It's only part of the picture, because although they are correct that electrons are coming out of many, many different structures like black holes, and it's coming out at almost the speed of light, it doesn't make sense until you see the other side. They're beyond the speed of light as to where these electrons are coming from. So what they are looking at in that theory is everything below the perception horizon. And they are totally correct in saying that there are things that are incorrect in the current theories. But because unless you put consciousness as fundamental, you don't understand the concept of the perception horizon, and then you don't understand that there are things beyond the perception horizon. And that's really the source of everything. So it's only half the picture. So, it doesn't make any sense otherwise why the electrons are going at just under the speed of light. They've only just slowed down to our dimension where we can detect them. And what the astrophysicists think is that these electrons are coming out of nowhere, because they don't actually know that there's so much beyond that we can currently measure. Yeah? Is this making sense to people? Okay, so this is the main principle that I'm going to talk about today. And so once you've understood that, you can understand how it relates to the flood and how it relates to the Shroud of Turin. Okay, so I'm just going to whiz through some slides to show that I'm not making everything up. Okay, so the way that the black hole principle, the black hole creativity shows up is as these bipolar jets. And some of you will know about geometry, sacred geometry. What I don't go into much is what's beyond the perception horizon, beyond what we're measuring. But I do think it is basically the geometry that the Kabbalah and all of these things talk about. So the process beyond the perception horizon is that step-down process through the dimensions, and that's what I think we have in those mystical traditions of sacred geometry. The end result that we can see are these bipolar jets. Do you see that? Now that's a Hubble picture of an actual galaxy. Now, as I said earlier, they want to say that it's this stuff going down the plug hole that is causing those jets. But actually, mathematically, it doesn't fit. Because if it really was the stuff going down the plug hole causing the jets, it wouldn't come out as those fine jets at right angles to the accretion disk. That plug hole is called the accretion disk. It doesn't fit, and I have been in physics conferences where they are doing mathematical contortions to try and make it fit. Instead of going, you know what, the theory doesn't fit the observations, maybe we need to change our theory. There's too much invested in the old ideas. So, again, this is another picture of bipolar jets. These are real telescope pictures. We can also look at, this is actually a galaxy. We can see, actually, it doesn't make any sense that it's falling in. What this is, a spiral galaxy, is bipolar jets that are spinning. Can you see that now? So you've got the jets that are coming out, there and there, and then as it spins, it creates a spiral. So it's sort of seeing lots of things in the same things in different ways now. That it's actually not a destructive force, it's a creative force. You even get a double helix coming out of some galaxies. It's quite rare, but it has actually been seen. We can now look back at all these beautiful Hubble pictures and just see how many of them have got sort of bipoles that you might not have noticed before. Yeah, and that's sort of the jet sort of spreading out over time. There's lots of pictures of that. But it's not just about the creation of the positron and the electron. They also cycle back again. So in the edge of the black hole, they're also cycling back again, and the two recombine and they form a gamma ray burst. Okay, so that's a type of light. A gamma ray burst is a type of light. So in other words, the positron and electron, the photon creates these to start off with, and then it kind of breathes back again. They recombine and they form a particle of light again in the form of gamma ray bursts, which is the sort of highly energetic light. So this is a flowing process that happens at the edge of the black hole. You know, it's a completely flowing, and I believe this is what we were talking about, the ancients were talking about, of the flow of the Tao, the sort of breath of Brahma, the dance of Shiva. Nothing is set. The breath, the change is all there is. You know, so at the edge of the black hole, that's what's happening. Now, for over 50 years now, scientists have been wondering why it is we see gamma ray bursts all over the sky. Where are they coming from? Why do they just burst periodically and disappear again sometime? At first, they were convinced that the gamma ray bursts had to be coming from inside our own galaxy here, inside the Milky Way, because they were so powerful. But when they started to realise they actually come from all over the sky, they were kind of worried because it breaks the known laws of physics. They were having to describe new laws of physics, such as, you can look this up, it's a real theory, doubly special relativity. Okay, so they were having to modify Einstein's equations just to fit this picture because they didn't understand where these gamma ray bursts are coming from. But now you're starting to see they're actually coming from the breath of the black holes, from all over the cosmos. Just again to prove I'm not making it up. So these are the gamma ray burst patterns. It looks like a very, very boring chart here, but the reason why I put it up is because their paradigm is a paradigm of violence. That something has to explode, something has to gobble something up in order to create power. Yeah, because it's all about physical reality. But if something were to really explode, then you would see a big burst, wouldn't you? And then you'd see a falling away. But you don't see that, and that's why I put this up. You see these fluctuations. And sometimes these fluctuations happen very, very fast. It really defies, their ideas about how things should work. And then they fall away again. And, sometimes you get these X-rays coming out. Now, X-rays are produced by high energy electrons. So, you remember I said the electrons sometimes come out? And they were expecting to see a pattern of the gamma ray burst falls away, and then the X-ray burst comes afterwards and then falls away, and they're thinking that's an explosion. That's not what they're finding. They call it an X-ray afterglow, but it's not an afterglow. They still call it an X-ray afterglow, even though it doesn't fit the pattern. As you can see, it does not fit the pattern of an explosion. So these do not fit. These are some X-ray fluctuations here, so these don't fit either. It doesn't fit the picture of an explosion. To the point where they actually came up with the concept of black holes burping on their food. And so do black holes play with their food? This is back in 2008, I think. 2005, sorry. And so minutes after the initial fireworks, remember their paradigm is very violent, they don't understand. But what is happening is that the X-ray flares, because they're coming in a way that doesn't fit their paradigm, they're calling it postnatal burps and hiccups. Because instead of just dying away, you get these fluctuations. It doesn't fit their current paradigm. So these are real scientific ideas. So the other big surprise about the gamma ray bursts is that we actually found them in our own galaxy. So I'll just play you that. Just need the sound for that one. Okay.
Extending above and below our galaxy's center.
This is the Fermi
These enormous
telescope.
gamma ray emitting lobes aren't immediately visible in the Fermi all-sky map. However, by processing the data, a group of scientists was able to bring these unexpected structures into sharp relief. Each lobe is 25,000 light years tall, and the whole structure may be only a few million years old. Within the bubbles, extremely energetic electrons are interacting with lower energy light to create gamma rays. But right now, no one knows the source of these electrons.
Okay, so you heard that. Nobody knows where they're coming from. So I'm not making it up. They really don't know these puzzles. Since that film was made, they did the resolution of the Fermi telescope even more. And guess what they found? Yeah? Does anyone know the name of these now? The bipolar jets. Yeah? The bipolar jets. So can you see them? Yeah? Okay, now this is our own galaxy. This is our own Milky Way. These are gamma ray bursts. These are gamma ray bubbles that the Fermi telescope found. To their surprise, they were not expecting this. And the headlines, this is in 2010, said the universe is blowing bubbles. So the galaxy is blowing bubbles. So can you see what's happening here? As these bipolar jets are spinning, they're creating those bubbles. Wouldn't you say that's pretty obvious? Yes. Okay. They don't think that at all because they're so blinded by their ideas that they are saying that this is a ghost of an explosion that happened many million years ago. So they actually are not connecting the two, which is just amazing. But it just shows how blind you can become if you are so attached to your theory. So this idea, this gamma ray versus black hole principle, I realised that it goes throughout the whole cosmos. After I had this amazing vision, this amazing experience, I came back home and I actually, sorry, my sound's still okay, I just knocked it a bit, yeah? Okay. So I came back home and I actually had this strong urge to go to sleep. This is back in 2003. And when I woke up, I realised I'd had a dream of the atom as the black hole. And that's all I needed. I realised that I could fill in all of the things in between. And I first published in 2003, just to, get it out there. And I realised that I could fill in a lot of the gaps. And since that time, it's been 10 years now, and before even I published Punk Science, the evidence was overwhelming. And believe me, I was sort of going, well, I'm a GP, It's like I'm trained as a GP, not a physicist. What am I doing going out talking about physics? What's everyone going to think, So, but the evidence got so overwhelming, and the predictions that were made in this theory kept coming true time and time again. That it just became too much, and I thought I really, really have to get out there. And luckily I heard about a team in Hawaii as well, Elizabeth Rauscher and Nassim Haramein, who'd done something similar. And they actually were talking about the mathematics. I was going, okay, somebody's doing the maths, so I don't have to worry about that too much. I will focus on what's been shown to me, the astrophysics. So according to the theory that I'm putting forward, these are the sorts of things that you should see around certain objects. If really the black hole principle is a principle, you should see that this at most levels of reality. And it expresses itself differently at different levels of reality. But this is what we should see. We should see these bipolar concentrated jets, the evidence of the sort of phi ratio, spiral geometry, fluctuating emissions. Remember I said they weren't like a falling away, they're actually a breathing process. And movement faster than expected, almost at light speed. Several different types of emissions actually come out, and you sometimes see evidence of new creation. You can actually see new blue stars within 1 light year of our own galaxy, and the astrophysicists don't know why. They actually don't know why they're there. Sometimes you see these magnetic fields, and you can sometimes see these fractal patterns. So I'm also going to reveal a new aspect of the black hole principle today. So again, these bipolar jets. You'd expect this to be a galaxy again, because, black holes, centre of galaxies, we know that by now. actually, this is a star. Okay, so the same pattern is happening at all sorts of levels of reality. You see these around protostars, you see these around protostars which are young stars, you see these around old stars, making people wonder, how do these old stars, they're supposed to have finished up their lives, how are they so powerful to be giving off these jets? And so you see them around planets as well. So our own star gives off these periodic ejections. We call them solar flares, coronal mass ejections, and they come from, guess what, the sunspots, which are black holes on black holes on black holes. So the sunspots are sort of the mini black holes on the surface of the sun, which are ejecting these things. They eject electrons, they're ejecting positrons, they're ejecting these brilliantly highly energetic radiation. You can see on the date that this is July the 9th, 2013. Solar flares fire off antimatter particles. Okay, so this is a surprise. Okay, so this is the first time researchers have observed antimatter coming from the sun. So this was not something that they were, so much predicting, but it fits the theory, it fits the black hole principle that we're talking about, that antimatter would come from the sun. So this is a film of Venus. Yeah, Venus was giving off a flare recently, and they didn't believe it was happening. They said it doesn't fit their picture. So they called it a lens artifact, because they really don't accept that this sort of thing is happening. Jupiter as well gives off these auroral flares, So, and also, I don't know, a few years ago, if anybody remembers, Jupiter lost a stripe. So you see these fluctuating patterns because, the same sort of principles in these flares are going on at every level of reality. Even comets, to their surprise, comets actually give off very, very fine jets. They expect comets to be these big icy balls, and to their surprise, when they actually started to look at comets with X-ray telescopes, they were seeing these fine jets of X-rays coming off. And they were like, well, what's going on? We weren't expecting that. So these are all periodic outbursts happening. Now, a lot of people in this room probably know a lot of theories about what the moon really is. Okay, so I'm not going to go into that. I'm just going to go into the discoveries that I have found and are putting forward. In that amateur astronomers were looking at the moon, and they've been saying for some time, you know what, the moon has eruptions. And the mainstream physicists were going, nah, these amateurs, they don't know what they're talking about, And so the moon doesn't erupt anything, it's the sun that does everything. The moon just reflects the sun. That's what we're told. Now, somebody fairly recently had the idea to actually collate all of the data, and when they actually collated the data, they realised that the data all matched up, as in what one amateur astronomer was saying was a flare happened in the same place to a lot of other people. So on the moon. So the moon itself actually has its own eruptions. It itself is actually giving off this periodic eruptions just like everything else. So is the Earth a black hole? Are we actually on a black hole? I mean, it sounds absolutely ridiculous, but actually there's so much evidence for the Earth showing this black hole behaviour more than most places. I mean, because obviously we can study it further. So, we can see the Earth's weather patterns, we can see these spirals, and there's also some very highly charged electrons that come from the sky that we're probably very familiar with. It's called lightning. And when lightning is discharged, it's going at a fantastical speed. By the time it hits the Earth, it's about the third the speed of light. Okay, it's very, very fast. Now, we are told that lightning happens because clouds end up getting too much static electricity. And the static electricity, anybody heard this one? Yeah? Okay. That, there's more evidence of fairies in the bottom of your garden, but never mind. So the static electricity builds up, and then it discharges, and that's where we get lightning from. Now, I was just talking to a 16-year-old the other day, and he looked at me aghast and he said, "But that's what's in my textbook." And it's true, this is what's in the textbooks, but there's no evidence for it. This is a theory that they put into the textbook as fact, but actually when people did the measurements did not add up. There's not nearly enough static electricity to create this sort of power. So what we do have, remember the pattern of black hole principle that we expect to see gamma rays, electrons and antimatter? Well, in the recent 20 years since the era of satellites, people have noticed a different sort of phenomena happening above thunderstorms, above the clouds. Gamma ray flashes, gamma ray bursts. And because I think they don't want to say that they're the same as the gamma ray bursts out in space, because this is Earth's upper atmosphere, we can't say that that's the same. They call them TGFs, or terrestrial gamma ray flashes. But actually, they are the same power as the terrestrial as a gamma ray burst we see out in black holes out in space. And they kind of are a bit uncomfortable about it because, it's flying in the face of everything that they believe in. So we have these sort of radial expansions. They're all named after, quite a lot of these are named elves and sprites and named after the fairy realm, which is quite nice. So we have these terrestrial gamma ray flashes. And, I think I put this in the wrong place, but, in terms of the Earth, we also know about these sort of vile vortices, a Bermuda Triangle, everything like that. Now, we could assign these and understand that actually these are sort of the black holes on the actual Earth. So, where things might actually go missing in the Bermuda Triangle because of the balance of matter and antimatter, might actually be creating an imbalance. So there could be something going on there, but obviously some more work has to be done. Now, what would we expect to find, if I was correct, that the terrestrial gamma ray flashes that we see in the Earth's upper atmosphere are the same as those out in space? Same as the black holes out in space? Sorry? Jets. We'd expect to see jets, so we do see the jets. We'd see the jets, absolutely. We see the electrons, and we see the gamma ray bursts. So NASA sent up a probe in, I think it was 2010, to investigate terrestrial gamma ray flashes because they didn't know what they were. And to their surprise, they discovered something rather interesting. Okay, I'll just play the film. So
at any given moment, about 1,800 thunderstorms are in progress somewhere on the globe. New observations by NASA's Fermi Gamma Ray Space Telescope show that thunderstorms make antimatter. The process starts with a terrestrial gamma ray flash, or TGF, an intense pulse of gamma rays originating from thunderstorms. These dots mark TGFs observed by Fermi's gamma ray burst monitor during the spacecraft's first 8 months of operations. Researchers estimate that there may be as many as 500 TGFs each day. On December 14, 2009, as Fermi passed over Egypt, it spotted a TGF produced by a thunderstorm in Zambia. The TGF was over the spacecraft's horizon where Fermi couldn't see it. So how could Fermi have detected it? Scientists believe that the TGF process begins in a thunderstorm's intense electrical field. Electrons within this field become accelerated upward. Above the storm, where the air is thin, the electrons can ramp up to speeds nearly as fast as the speed of light. When these ultra-fast electrons encounter an atom, they emit gamma rays. Very rarely, one of these gamma ray photons grazes an atom and transforms into a pair of particles. One, an electron, is normal matter. The other is antimatter, the electron's opposite, called a positron. The gamma rays travel in straight lines, but the charged particles spiral along lines of Earth's magnetic field. And that was the route to Fermi.
Okay, so most of that mechanism you can ignore because the actual part that was most important was scientists believe. Okay, so she put the word scientists believe, and don't you think she was sounding very convincing? that they know how this happened. They don't. It was a total shock. So what they tend to do is they go, oh yeah, we meant to find that. We meant to find antimatter coming out of thunderstorms, yeah. This is how it happens, and they give you this really convincing sounding explanation that they then put in the textbooks. And then somebody wins a Nobel Prize for it and then dies, and then it gets enshrined in science, and then nobody ever questions it. And that, at the moment, is how science progresses. So, but you can see the features of the black hole principle that they have found. They don't understand why, but can you see that? The electrons going almost at light speed, the gamma rays, the antimatter which they weren't expecting, and the spirals. They don't understand why they're happening, but of course, when I saw that, I was just amazed because it's exactly what I was predicting. I published first 10 years ago, and this was discovered in 2010. So, a sign of a good theory is that it makes predictions that come true. And this is just another slide on that. And very, very ironic. We know in detail how black holes work at the centres of distant galaxies, but we don't really understand what's going on inside thunderclouds just a few miles over our heads. Not understanding that they, first of all, don't know how black holes work in the centre of galaxies, and it's the same thing. So, we actually have amazing evidence for the black hole principle operating in the Earth's upper atmosphere. Okay, so this is quite, can you see this is quite recent as well, to 2010? They found antimatter coming from the Earth's interior. Now, we're told a story again. It's a story that the Earth is made up of an iron molten core, because they're trying to understand why the Earth has fluctuating magnetic fields. Okay, but actually we don't have any evidence. We've never been able to look into the Earth's core. So what happens when we actually look into the Earth's interior? We find antimatter. The neutrinos, antimatter counterparts, which are called, they're called geoneutrinos, to say that they're coming from the Earth. Again, totally unexpected. Now, these are some emissions that you might be familiar with. Volcanoes. Can you see the lightning coming out of the volcanoes? Okay. And can you see these plumes going in spiral? Okay, so it's a bit darker, but the lightning is happening at every single level. So if I'm correct, we should be seeing evidence of antimatter coming out of volcanoes. And we're told, aren't we, that volcanoes are this lava that comes up through the earth, and we're told stories. And we've shown in our textbook in school that it actually comes out in a sort of gigantic plume that just goes like this, sort of randomly sprayed. These are spiral plumes, and there are actually scientific papers studying these mesocyclones, they're called. Okay, because it was totally unexpected. As I said, what I realised is that the atom 2, it goes all the way down. The atom 2 is showing the black hole principle behaviour. You've got the radioactivity, for example, you've got the gamma rays, you've got the beta particles. I do have some evidence about alpha particles going at different levels, but it's a lot to go into. You may recognise, this is from Bruce Cathy. So he was talking about the cycles. And if you look at an atom again, you've got electron and positrons combining, making light. And it's breathing. The electrons are going up and down what we call the electron, shells, we call them quantum leaps. And we use this in our everyday life. We use it in neon lights, for example, the lights that's given off. When we look at it again, it's the same pattern. We just have to sort of reframe it. This is it's a bit freaky, that cover. It's covering New Scientist. Black holes are living inside you. When you redefine black holes as, the infinity at the centre, they can be everywhere. And this is mainstream science. Chakras, we can re-look at chakras now. Chakras are these vortices that are in our bodies that create our bodies. And we can even detect little sort of electrons coming off, little particles coming off these chakra sites. Previous scientists have actually done this. And DNA, we know that some work has been done that DNA gives off light, that it winds and unwinds according to people's emotions. Isn't that amazing? So we have that idea. So now, what about the Big Bang? I started off with the Big Bang because if I'm correct, the Big Bang didn't happen. Because we live in a universe of continuous creation where things are created at every single level of reality as a sort of fractal all the way down, from those supermassive black holes in the centre of the galaxy all the way down. So what does that say about the Big Bang? It says that the universe did not get created in one moment. It's a universe of continuous creation. Now, when they actually did the proof of Big Bang, it's something called WMAP data, this is supposed to prove once and for all. They were looking at the background microwave radiation, which was supposed to have been a snapshot of the Big Bang 15 billion years ago. But unfortunately, they kept seeing alignments within the data, which made them actually question everything. And they actually call this the axis of evil. So I'll just let Joao tell you about this.
There should be no pattern to the distribution of different temperatures across the sky. But I found that there did seem to be some order to the arrangement of these fluctuations. The pattern is so subtle, it only emerges when the complicated WMAP picture is broken down into a series of more simple temperature maps. The Big Bang theory predicts that the universe is the same everywhere, and the arrangement of the different components should be completely random. But it isn't. Some of the temperature maps turn out to have features in common.
They align along one special direction, which I dubbed the axis of evil.
I call it the axis of evil because it implies there is a flaw in the Big Bang theory. Some people thought I was seeing things that weren't there. But complex statistical analysis proves that these alignments aren't just due to chance. The axis of evil really is present in the data.
So these are mainstream physicists, and they're finding alignments to current structures. It should be a picture of 15 billion years ago, but it isn't. And Scientific American actually ran an article that said, "Is the universe out of tune?" saying if this data's correct, then we have to throw out Big Bang theory because it can't be right. You know, so definitely the evidence isn't. So we have this background microwave radiation, and what have we also found? Microwaves coming out of the centre of galaxies. So the background radiation that was supposed to have been the proof of Big Bang is actually proving even further the black hole principle. Because as I said, too much to go into in one day, but lots and lots of different types of radiation come out of black holes. So the background microwave radiation is not a picture of the Big Bang. It's a picture of the microwaves that are currently coming out of black holes everywhere. So, and when they found this, they were really, really surprised. But you can see the microwave haze is being emitted from a region surrounding the Milky Way's core. We found microwaves coming out of our own galaxy. They're probably coming out of every galaxy. And that's the reason why we see alignments in the data to current structures, because they're coming from current structures. Yeah, does that make sense? So we have to look again at the Big Bang. And so, you know, we have this universe now, this idea that everything is working on the same principle. Now, I promised you that there was some new data today, and it's all about water. Okay, so this is the big surprise. But if you remember that I said earlier that I started to realise that the terrestrial gamma ray flashes in thunderstorms were the same as the black holes out in space. And, you know, before I published Punk Science, I was pondering on this because I was like, well, hang on a minute. The other thing that happens in thunderstorms is it rains. So where the water is produced, I thought, oh my goodness, I can't say that rain comes out of black holes. You know, everyone's going to really think that I'm nuts, but I started to look into it, and I realised that, you know, that people actually don't know why. This is from New Scientist, April 2005. People don't know why some clouds rain and some clouds don't. You know, we've been told that there's a water cycle, that rain gathers over the sea and it goes over a mountain and then it starts raining, but not all clouds shed their water like that. So even in the mainstream climate science, they actually don't understand. If you can see this, they are fudging the inner mechanics of clouds. You know, they don't actually know. We have models, but we don't know for sure. And you don't find that on the daily weather, do you? So this is something that has been found recently. Absolute surprise to me. Black holes spew water vapour. So black holes in space are actually emitting water jets. You know, H2O water jets. They're mixed with microwaves, so they're called masers. And one of the biggest bodies of water ever found is out in the deepest regions of space. Can you see that, the vapour? Okay, so I didn't have this information when I published, and I really don't sort of make that prediction, but it's a prediction that all black holes must have something to do with water, because we see rain coming out of the black holes in the Earth's upper atmosphere. And now we have the evidence that black holes in space spew jets of water. And it actually is happening at every single level of the universe. So we're finding water everywhere. And that's the reason why we have a drop to drink. Because water is produced at every level through black holes in jets. Can you see all that? This is one of Jupiter's moons. Water. This is our own moon. People always said that water does not exist on our moon. It's found at the poles. Saturn's moons, water. We're finding H2O everywhere. This is a galactic geyser coming out of a galaxy. It's giving off water. You know, there's actually no comment at all because it's completely unexpected. This is a comet. Comet Halley. Can you see this is H2O vapor coming out of a comet? And, this is completely unexpected. They weren't expecting. Back to our earthquakes. This is an earthquake. Can you see that? This is something called liquefaction. That happens during earthquakes. The water isn't the soil dissolving. The water is being produced by the black hole erupting, causing the earthquake. You know, when you look into seismology, you realise they don't know really why earthquakes happen. They don't know when they happen. You know, they say there's these tectonic plates and they're rubbing against each other. Well, if that's the case, you should be able to predict earthquakes. But they can't because they don't really understand the mechanism. And what we do see is water coming out of these earthquakes. Anybody remember the ash cloud in Iceland a few years ago that disrupted a lot of travel? It wasn't ash because there are hardly any trees in Iceland. It was actually water vapour. So volcanoes, again, can you see that? 60% of volcanic gas is water. So volcanoes, again, are eruptions of black holes that are emitting water. And, there's a big question, how did water get to Earth? And so this is a real question, we don't actually know. Now I'm putting forward, obviously in this theory, that you have a central black hole of the planet, and as that, creates the matter and the antimatter and creates everything, you actually get water emitted as well. It's a big mystery. If you ask most people, it was seeded by an asteroid. If you ask most scientists, that's what they'll say. It's just a guess. We don't know, and it is a mystery. How did we get so much water on this planet? So I guess you're guessing what's coming next. What has this got to do with the flood? Well, if we had periodic ejections of water from a central black hole of the Earth, this could have been what caused the massive rise in water on this planet that gave rise to all the sort of flood stories. And this is one you might not have heard, but people in sort of Easter Island
came from a lost island continent known as Kiva, somewhere in the Pacific.
Luego Victoria de puede ser de que cuando el continente iba, se hundió una explosión, desaparecieron y toda la gente emigraron.
So that's something that, you know, there's many, many flood stories around the world, as you're probably very, very familiar with, from Graham Hancock, and the theories of how the flood came to be, you know, just don't add up with the ice caps melting. How do ice caps melt that fast? There wasn't enough there either. You know, so what I'm proposing is, you know, from the central black hole dynamo, you know, this could be, you know, a major sort of black hole emission, even a polar shift. And this could have led to a major outburst of water from the central black hole of the planet. We now know that black holes out in space actually emit water. We now know that the Earth is fitting with black hole behaviour, you know, creative black hole behaviour. So this is what I'm putting forward as perhaps a mechanism of why these periodic floods happen. Because periodically, just like you get coronal mass ejections, you know, on the sun, you get a very, very big explosion of the, emission of the black hole at the centre of the planet, and that's probably led to the flood. Okay, this is obviously to be confirmed, and you know, I think this is Edgar Casey. Sorry.
Events are increasing. The torrid zone activity has increased, along with general world increase, by something like 500% in the last 50 years.
Casey also predicted a surge in violent storms and earthquakes in this period. In the last 10 years, hurricane activity in the Atlantic has been at its highest since records began, and an increasing number of earthquakes are being detected around the globe. In 1999, German researchers measured more than 200 earthquakes in a period of 7 months above the Arctic Circle.
So we're definitely seeing these changes, and probably, and don't forget this is all linked to consciousness, as the underlying consciousness of not just the planet, the whole universe probably, because it's all linked. Every single centre, every single singularity, every single black hole is the same. It's the same one singularity, it's the same infinity. You know, at every single level that's giving rise to what we call reality below the perception horizon. So I think as the centre of the planet and all the consciousness is changing as we're evolving, this is what's giving rise to these major black hole ejections, and that's why we're seeing more earthquakes. Okay, I've just explained how it fits all the black hole behaviour, and obviously there's more work to be done on this. But, you know, we're starting to see a unified theory. So this is my new theory of the flood, as I've said, and you know, we're starting to see a way that we can unite everything from consciousness to galaxies out there, to lightning, to thunderstorms, to, you know, what's even in our own body and our atoms. So you might be wondering, okay, she's almost got to the end. What about the shroud? That's what I came here for. You know, so if you want to see my full talk on the Shroud of Turin, it is actually on YouTube. And so if you actually go to YouTube and have a look, Shroud of Turin and black holes. So obviously I've got very, very little time to talk about it today. But, you know, I'm putting forward a new possible theory as to how the shroud was created. And if anybody heard Andrew yesterday, he gave an excellent talk, also a medical doctor as myself, so got the scientific background. I was not brought up in a religious way, and I also but the reason why I got into this is for my new book. I've been having these visions of Mary Magdalene and various sort of things for about over 10 years. As I said, I'm a mystic, so I tend to get these things, and I've been thinking, what's it got to do with me? You know, so I'm starting to put all this stuff into a new book, and part of that is to actually look at the evidence for Jesus' existence. You know, did these people actually exist? And part of that, obviously, is the shroud. So, if for people who don't know, the Shroud of Turin is a very, very special cloth that's been kept in Turin, obviously, and the big startling discovery was about 100 years ago when they found that the actual image in the cloth is actually negative. And when they took a photographic negative, they got the positive, as it were, and nothing else does this. You know, they've never found anything like that does this. And when they actually found that, they could see all the definitions of the face, etc. I won't go into all of this, as I said, I do go into a lot more on the video on YouTube. But there's a lot of forensic evidence that we just can't explain. For example, medieval artists, if it was an artist, would have put the nail depicted through the hand, and it's not, it's through a space sort of behind the thumb, and you can see the contraction of the median nerve. There's marks of a Roman flagrum, which is, you know, a definite weapon that they were used to whip. You can even tell the heights, the different heights of the Roman soldiers. One was taller than the other that were whipping this poor individual. You know, whoever he is, you know, there were, you know, there's all sorts of things on here. You can, a forensic pathologist can go through this and do a full post-mortem. It's that realistic. They can tell where the person's hands were straight after death. There's so much detail that they can go into. And how many people were in the talk yesterday? Most of you, so I don't need to go into too much. What Andrew didn't mention as well is there's something called the Sudarium. Has anybody heard of that? There's another cloth. There were actually quite a few cloths. One cloth was actually destroyed in the French Revolution, so we'll never be able to really analyse that. There's another cloth called the Sudarium, and unlike the shroud, we have a very, very clear history of that. We know where that came from. That came from Jerusalem. That came to Spain. It's called the Sudarium of Oviedo in Spain, and it doesn't have a huge fanfare about it, but we know where it is. We know where it's been since the 6th century, and it's been very good records have been kept. Now these bloodstains on this Sudarium, now the Sudarium doesn't have an image, it has bloodstains, and it even has little sort of pinpricks which people have suggested actually have come from the crown of thorns. But these bloodstains match completely in blood type and everything the actual shroud of Turin. When you lay one over the other, it wrapped the same face. Whose face it is, you know, we may not be sure. There's also, so this goes back to the 6th century. So the Shroud of Turin must go back at least that time. So we also have something called the Praying Manuscript, which was, I think, in 1190, created then, which actually depicts the sort of weave of the shroud, you know, being laid down. So there's all sorts of evidence. There's something, Andrew yesterday talked about something called the Mandylion. So we think that the shroud was actually an object called the Mandylion before. That was what it was called. And it was folded up to just being a head. And it went from, it was actually ended up in Constantinople before it went to Europe. I've actually pieced together a bit more of the story, I think. And I think from Constantinople it went to Athens and then Florence. And this is the Duke of Athens escaping with a cloth with a face on it. And I've actually found that there were 2 pieces of paper after the Crusades in Constantinople. That, you know, I don't know if you know this, the Crusaders actually ransacked their own people, their own religion. You know, and they divided up the booty. One of those things was the Shroud of Turin. So that, I think that looks like the missing piece. Athens, then Florence, then France, which it famously appeared. And, you know, Andrew also went into the carbon dating fiasco that although they actually took you know, they took a patch that happened to be that actually was repaired in you know, many hundreds of years ago after a fire, and so although they got the dating right, it was the wrong patch to be looking at, and the original scientist, the original chemist who actually worked on the shroud agreed with that. This is M. Sue Benford, who has now passed away. She was the woman, the nurse in America, who actually said, hey guys, it's a patch. But interestingly, she got it from a channeling. She actually was channeling. She thought to herself it was something completely different, but it actually came from a channeling that she did. So she's a registered nurse, so she was able to do the sort of scientific side as well. So what really caught my attention though was this in a documentary. Now this is a physicist and artist who had something very, very interesting to say about the shroud creation. Can you put the sound up for this one, thank you?
When you look at the image of the shroud, the 2 bodies next to each other, you feel that it's a flat image. But if you create, for instance, a 3-dimensional object, as I did, the real body, then you realize that there is a strange dividing element, an interface from which the image is projected up and the image is projected down. The muscles of the body are absolutely not crushed against the stone of the tomb. They are perfect. It means that the body is hovering between the two sides of the shroud. What does that mean? That there is absolutely no gravity.
Okay. Now, I think you know what I'm about to say. Now, Andrew went into this a little bit, that the muscles were not crushed, and interestingly, he said the hair was not back, as it would be if it was someone lying down. It was actually still kind of on the shoulders. So that is interesting. So you've now heard me talk about the whole universe working in a way of sort of bipolar jets. And what do we have here? An image that was created as if the body itself was a black hole, emitting radiation in a bipolar jet. Does that make sense? Okay, so, just to honour Andrew's talk, we'll put him that way round, because Andrew said actually the hair suggests that this person was not levitating that way in anti-gravity, but was actually levitating that way. Now, I've just talked about the evidence for this happening at every level of the universe. It's possible that somebody who is so adept could actually change consciously their matter and antimatter into light and become themselves a gamma ray burst. Okay, now we can't actually test this at the moment, because guess what? Gamma ray burst holograms, which is what this could be if I'm correct, are beyond our current technology. We've got as far as X-ray holograms, but we can't actually at the moment create gamma ray holograms. So this could be what caused this sort of scorch mark on this cloth. It could be that this person is highly adept, which would fit with somebody, this is Jesus, with somebody who could do miracles and all sorts of things. On a personal level, I actually had a vision some time ago. I was called to the Galleria Shopping Centre in Hatfield by Spirit, and I was going, okay, what is it I have to find here? New coat, I don't know. And I was wandering around, and I was very disappointed because I couldn't find anything. And then there was this little cart in one of the forecourts, and it had crystals on it. And I knew a crystal was calling me, and I just went over. There was this tiny crystal, I forget what it was, and it was about £2. And I took it home, and that night I had so many visions. And one of them was just like this, and it was Jesus sort of getting up. And I said, how did you do that? And he said, because I went to India and I learned how to do this. And I was like, okay. And I saw that his head was on a pillow. Now, at this time, I didn't know anything about Jewish burials at that time in Jerusalem, but you can actually see that there was the head slightly tilted forward on the shroud. They've actually done that analysis with modern computers, and they discovered. Now, I know I'm really racing through this, but there is some evidence that Jesus, there's some people who say Jesus actually did go to India. And this is stuff I found later. There's a guy called Nikolai Notovich, who has published a book about 100 years ago called The Unknown Life of Issa. And he supposedly found this manuscripts in a Tibetan monastery. He broke his leg, and he managed to persuade them to copy these texts. And so he copied these texts, and nowadays nobody's heard of it because it's been totally discredited. They said he never even went to Tibet. I promise you, get that book on Kindle, it's about £1. And read that, because most of it is a travelogue of Tibet. And it's probably a Tibet you don't even see anymore. So this person definitely travelled there. And what's interesting is that what is said in this unknown life of Issa, which is another name for Jesus, is very similar to what was recently found on the Jesus wife papyrus. There are some passages which, even for Victorian times, the Victorian and European, are very, very controversial. Hearken, respect woman, for in her we see the mother of the universe, and all truth of divine creation is to come through her. Now, do you think a Victorian would make up that Jesus said that? It just seems a bit unlikely. I'm not saying that this is proof, But the language is similar to the recent Greek papyrus, the Coptic papyrus that was found. My mother gave me life. Mary is worth it. My wife, she will be able to be my disciple. Do you see what I mean? The language, there's some similarities. It doesn't say that it's proof. But it just gives that another dimension to whether or not Jesus actually went to India and learned how to be an adept. Tibetan monks still to this day, they, you know, we've had, where's my partner? He's done some research on people actually dematerializing at death. You know, there are all sorts of things, people actually emitting sort of fire and all sorts of things. So, you know, we're looking at a universe now of like this continuous creation universe, you know, that's happening at every single level. You know, we are part of this magnificent cosmos. And, you know, it's just, you know, at every single level inside us, creation is happening. It goes down to infinity, and it's all linked to consciousness. Once you understand that first principle that we took from quantum physics, you're thinking, oh, that was a long time ago now, it should be going on for ages. Right, so I want you to leave you with a trailer for a movie that's going to be coming soon, Punk Science, a movie. If you, there are a few books, sorry, I've just come from California, I didn't have enough books out in the room, but there's also a board where you can sign up to put your name down and email for learning more about Punk Science, a movie, if you're interested. Okay, so I'll just put, do you want to see the trailer? Have you had enough? Or, yeah, okay. Okay, we'll just put it there.
This is a wonderful time in our history right now because we're changing the basic paradigms of science.
We are saying the universe looks differently to how we previously thought. We're saying that consciousness is at the heart of the universe, and we don't need permission. This is in your face. This is something that is breaking through the old paradigm, and that's really the spirit of punk science.
Punks are the ones who challenge the authority.
Physicists would actually entertain such a ludicrous speculation.
Big Bang did not happen. Science is shifting now. East and West are kind of coming together.
The new ideas are actually coming outside of academia.
Black holes.
Black holes are black holes.
Black holes, black holes.
Black holes are actually creative. They're actually the creative sources of the universe.
Black holes play a fundamental role in the universe on all scales, from the very largest to the very small.
Black holes are absolutely fascinating.
We're actually living in a black hole. It's the breathing system of the whole of the multiverse, and without black holes there is nothing.
It's a paradigm which understands consciousness.
Consciousness is an actual something.
Consciousness is recognized as the primary being.
Not only is it the supporting foundation, it is everything.
But this has huge implications for science.
I think that the implications really are vast.
All that we call reality is consciousness.
Everyday waking awareness is a very thin slice of a much, much larger and multidimensional picture.
What about breaking the light barrier? Now, the speed of light is pure movement.
What we call the speed of light is pretty much the outer range of this construct.
But the physical body is just a manifestation of the super energy body.
The energy is also representing information.
The body is simply energy. It's simple as that. And technically it's not even energy so much as consciousness.
We're now on the threshold of an even greater, even more radical revolution in our understanding, not just of the physical world, but the entire nature of reality. It will ultimately become the new idea.
For people to really come to understand themselves and to love themselves and see others as themselves and see us all part of the larger whole.
there, so applause to them. Thank you very much for listening.
Take 10 minutes of questions, yeah?
Okay, we have 10 minutes left for questions, so if anybody has any questions, this is your moment. Do we have any questions still? Yes? Had to be right up at the back.
Some people are saying blue flashes in the sky, there'd be gamma ray bursts, and has the sun moved?
Has the sun moved?
Saying strange things about radiation, different spectral energies.
I mean, this is the sun is moving all the time because we're actually sort of spiraling through space. But what this theory allows for is all those changes, and absolutely, there's blue flashes. You mentioned them yesterday, and we were talking about these blue flashes, these flashes coming out of the Earth as well. Well, this is all fitting with what we'd expect as well. So the blue flashes in the sky. Sometimes we can see spirit flashes that aren't in this dimension. So that's the other thing that mystics can actually see those. But yeah, absolutely, this is all fitting with the sort of plasma theories are talking about everything below the perception horizon, where you have these electronic discharges. So that's below the perception horizon. But the origin is beyond the perception horizon in the infinite realms, and the higher dimensions. That's where it comes from. But it manifests as those blue flashes. So absolutely, it fits.
Lady here, I think. Hold on.
Hello, yes, I'd like to ask you a question in the context of X3, which is a twin star in Cygnus constellation. We're told that the black hole accretes matter and then from its twin star and then blows it out as a bipolar two light rays, but it can't in what you're saying. How do you explain that it manages to accrete matter or light from somewhere and then blow it out into bipolar rays?
Okay, well, the current theory is that black holes gobble everything. But the observations don't match that theory. So when they see in their observations, because remember we've only had these deep space telescopes for 20 years or so, so when they see the observations of the bipolar jets, their ideas are still stuck on the idea of the accretion disk. What they say is that everything heats up, but if you can imagine it heats up and that gives off the jets. But the trouble is the maths just doesn't add up. The angular momentum and all of that sort of stuff doesn't add up on that. And I've been at physics conferences and sat through this explanation just to make sure I got it right before I actually publish, because I have gone to great lengths to spend time with physicists, mainstream physicists. And so I was actually at a conference of the Institute of Physics. And if you can imagine what an accretion disk really would do, it's like a Catherine wheel. You see sparks coming off a Catherine wheel to the side. That's what not coming perpendicular to the accretion disk. These are the stories that they're telling people because they actually don't know what's going on. And, gradually maybe we'll see a shift in realising that it's impossible. And to make that mathematics work, you really have to work hard. They've done it, but it's not simple. And the universe is elegant and simple, and it gives out, it breathes the power it brings out is almost effortless power. The gamma ray bursts that defy the laws of physics are giving off so much power, they don't understand it. But actually they only understand in terms of physical collisions. When you actually look at the breathing, the effortless breathing that's coming from infinity, it's infinitely powerful, but it's also effortless in a way. Do you see what I'm saying? And that's the paradigm we need to shift to.
Okay, I think we have a question down here.
Thanks, very pretty fascinating. Physics was my subject, and I haven't studied it for a long while. I'm pretty ashamed of that. What I am concerned about is what CERN is getting up to. I'm pretty concerned about the psychology and the personalities of the people involved in CERN, who think it's a great joke that anybody would think that black holes might be a problem. But we must be very careful things with some kind of rather cheap firework display, which could produce this, that, and the other, as all sorts of things can produce in subatomic physics. But let's not forget that the accretion of matter is the structural prerequisite for black holes. And I think what really scares me about it, it's part of the excitement of learning about the universe and the whole thing. I mean, it's wonderful to talk, brilliant. Is the psychology of these scientists who got hold of a big, powerful machine, and they want to make it do big, powerful things and be big, powerful, influential people, almost like gods. And this is the kind of language that is going around. I'm quite sure that what they want to do is to say, well, actually, we could have instead of a wind turbine, we have a black hole, in their black hole. And then we have lots of free power for everybody. I think it's very worrying, and I do think that we should be aware of that. Don't you agree?
Yeah, the greatest scientific leaps don't happen by big tunnels and particles. I mean, it don't happen so much by equipment necessarily. The greatest leaps that we've known about are people's consciousness becoming one with the universe and the universe revealing it. And for Einstein, it was dreams. For Faraday, he had visions. There's all sorts of people throughout history. Kekulé had a dream. It doesn't involve all this equipment. So I totally agree with you, but I also think that we've got to get out of the concept that this disk is the accretion disk going down the plug hole. It's not. It's the creation disk, which is why you see new stars forming so close to the black hole at the centre of our galaxy, because it's actually a creation disk. So they're still stuck in that paradigm. So they're still talking about the accretion disk. It's not. It doesn't accrete. It's actually creating. It's actually breathing. And we actually have evidence for that. They have discovered clouds of gas a few light years away from the centre of the Milky Way, breathing in and out, and they don't know why. Obviously it fits the theory that I'm putting forward today. We have to take that leap and go away from black holes being destructive to them being the creative centres. It fits all of the data and it makes predictions. And no theory that I know of predicted that water would come out of black holes. I haven't heard of any theory that did that, but that was something that was put forward years ago. And that's through insight, not through a particle accelerator.
One last question.
Hi. So what you're talking about these things, although you call them black holes, they're not really black.
That's right. Yeah.
But is there essentially another body that's opposite to that then? One time they talked about white holes and black holes, but it's almost now that what we're calling black holes fit more the white hole discussion of something spewing matter into the universe, which you're talking about.
Yeah, I think people have touched on this before, saying, with every black hole there's a white hole. But I think the reason why I'm calling it the black hole principle is because at the moment within science we call these structures black holes, but really, as I said, they're not really black holes, but it's kind of a bridging term. David Ash, who you saw, I don't know if David Ash has spoken here, on the thing. I mean, he's come up with a theory calling it the vortex theory, that there's a vortex at every single level of reality. So there's a few people who've spoken about that. There's people, even people in ancient times used to talk about the mother goddess being at the centre of the galaxy. The Gnostics talked about creation coming from the centre of the galaxy. It's had many names throughout this time. The reason why I'm calling it black holes at this time is because that's the term we use for the structure of the centre of galaxies right now. But the name really isn't important. It's the principle that's important. And we'll probably change the name in future because we'll say, well, we got that one wrong. It's not really black. So absolutely.
Well, I'm afraid there we must leave it. So much more to say, I know, but you've certainly given us lots to think about. So thank you so much, Manjir Samanta-Laughton.